Shri Gurave Namaha students, welcome to online class. In miscellaneous exercise, question number 13, I am going to discuss today, right? Find the points at which the function f given by f of x equal to x minus 2 the whole power 4 into x plus 1 the whole cube as local maxima, local minima and point of inflection. Before and all I used to teach, right? First order derivative, first step, you have to equate with 0, then you find the critical point, then the critical point you have to substitute in the second order derivative. If the second order derivative is greater than 0, local minima. If the second order derivative less than 0, local maxima, I said. Here one more interesting concept is there. Using the first order derivative itself, we can say it is local maxima or local minima. That I am going to discuss today. You have to listen carefully, children. Right? First I will give the note. Then I will explain. Note. Point 1. Right? If at any point, first you should listen, then I'll explain through the sum. You feel easy. F dash of x changes sign from negative to positive. From negative to positive. Then f of x as a point of local minima. At that point. Right, children? At that point. I will explain in the sum, then only you feel easy. First I will give the note. Next, if at any point f dash of x changes sign from positive to negative, then f of x has a point of what? Local maximum. That's it. As a point of local maximum at that point. I will explain that, right? At that point. The next one, they are expecting point of inflection. If the second order derivative equal to 0 means you can say that point is a point of inflection. If it is in the first order, how it should be, you see. If at any point f dash of x does not change the sign. Does not change the sign, then f of x as a point of inflection. Right? Through the first order derivative, you can say local maxima and local minima. Point of inflection. When it is possible, that also I want to explain to you, children. Right? First step, normal procedure, you have to differentiate the given function. Right? What is your given function? First, solution f of x equal to x minus 2 the whole power 4 into x plus 1 the whole power 3. That is your function, right? Here you are going to apply product rule. The derivative of uv is nothing but uv dash plus vu dash, right? Anyone you can take it as u. F dash of x equal to x minus 2 the whole power 4, 3 into x plus 1 the whole square plus x plus 1 the whole cube, 4 into x minus 2 the whole cube. Got it, children? U b dash plus v u dash. Now I am going to simplify. Which term is common in both the things? X minus 2 the whole cube and x plus 1 the whole square. The least power you should take. X in 3 into x minus 2 plus 4 into x plus 1. Got it? Now, x minus 2 the whole cube, x plus 1 the whole square. Now, 3x minus 6 plus 4x plus 4. Got it, children? Now, what can you get? A critical point you want to find, right? Which is equal to x minus 2 the whole cube, x plus 1 the whole square, 7x minus 2. The next step, f dash of x equal to 0, which implies x minus 2 the whole cube, x plus 1 the whole square, 7x minus 2 equal to 0. Now, x is equal to 2, x is equal to minus 1, x is equal to 2 by 7. One thing you have to listen, children, when you differentiate the function again, you will get it as 3 times x minus 2, like that. The same thing it will come. If you substitute the critical point, you cannot give. If you substitute the critical point in the second order derivative, you cannot say anything. You can say only the point of inflection. For that purpose, we are going to enter into the first order derivative, right? See, now at x is equal to 2, here we are going to assume, what you are going to assume, you see, f dash of x, here you write x minus 2 the whole cube, x plus 1 the whole square, 7x minus 2, then the result, right? X you are going to assume first less than 2. The first order derivative you are going to assume as x value is less than 2. Less than 2 means what are the things you can take? Less than 2 means what are the things? 1, 0, like that. The first part, when you substitute 0, for example, what can you get? Negative. Here it is positive. Here it is negative. Got it, children? Say yes or no. When you substitute x is equal to 0, here you get it as negative. Next is positive. Next is x is equal to 0, you will get it as negative. Suppose if you are substituting x is equal to 1, you will get it as positive. The result is negative. First, nearest value. What is the nearest value of 2? 1. That you have to substitute. Next, greater than 2. Greater than 2 means what can you get? Nearest 2. What is that? 3 you can assume. Here it is positive, positive, what? Positive. So what is the result at the end? Positive. See, the first order derivative changes from negative to positive. The first order derivative negative to positive. That means the point, that point, right? F dash of x, which is that point 2. That point is local minima. F dash of x changes sign from negative to positive. Negative to positive. Therefore, x is equal to 2 is a point of local minima. Local minima. Slight difference you are taking, right? Next, at x is equal to minus 1. At x is equal to minus 1. F dash of x the same. X minus 2 the whole cube. X plus 1 the whole square. 7x minus 2. Here also you are going to take less than minus 1. Less than minus 1 means which is the nearest minus 2. So what can you arrive here? Negative. Here positive. Here negative. Right? Then negative. See here negative. Sorry children, the previous one I commit mistake I think. 1 minute. Whether it is mistake or not, I want to check. Right. 1 minute. Positive, negative. I didn't commit mistake. Right. Now you see the slight change. Got it? Now you see here, what can you arrive? Negative, positive, again negative. The result what you arrive? Positive. Because everything it is in the form of multiplication. F dash of x equal to x minus 2 the whole cube into x plus 1 the whole square into. So negative into positive, positive into negative. So you arrive positive. Greater than minus 1. Which can you take here? Nearest value 0. Right. So here it is negative. Here it is positive. Here what can you get? Negative. So you arrive the result as positive. See here the f dash of x does not change the sign. Does not change the sign. F dash of x does not change the sign. If does not change the sign means that point, what is that point? X is equal to minus 1. The x is equal to minus 1 is a point of inflection. Point of inflection. Local minima we finished. Point of inflection we finished. One more thing is left. What is that? Local maxima that we are going to do now. At x is equal to 2 by 7. At x is equal to 2 by 7. F dash of x. X minus 2 the whole cube. X plus 1 the whole square. 7x minus 2. Here you see less than 2 by 7. Less than 2 by 7. That means you will get it as negative. Here it is positive. Here it is negative. Right? Less than 2 by 7. When you take LCM, you will get it as negative. Result what you arrive? Positive. Result what you arrive? Positive. Here you see greater than 2 by 7. Same. Negative. Here 2 by 7 means the next value. Positive. Here positive. You will get it as negative. F dash of x changes. F dash of x changes sign from positive to negative. Positive to negative. That means that point is local maxima. X is equal to 2 by 7 is a point of local maxima. Got it, children? What are the things they expect? That everything we completed. One more time I will explain. You have to listen because it is entirely different. Now you see f of x, f dash of x you arrived, right? Now what is the critical point you found? You see x is equal to 2, x is equal to minus 1, x is equal to 2 by 7. Using first order derivative itself you can say local maxima and local minima point of inflection. See, when you differentiate the function again, you will get it as x minus 2 and x plus 1 and 7x like that. If you substitute the critical point, the second order derivative will act as 0. Point of inflection you can get, but we cannot say which is maximum and which is minimum. For that purpose, the first order derivative itself we can conclude. How we can conclude? We are assuming, right, the point less than 2, greater than 2. You arrive the result as negative to positive. F dash of x changes, sign changes from negative to positive means that particular point. Which particular point? We are assuming less than, greater than, no. That particular point is local minima. Then x is equal to minus 1. The derivative does not change the sign. Therefore, that point is a point of inflection. X is equal to 2 by 7. Here your result is positive to negative. F dash of x changes sign from positive to negative. Therefore, that point is a point of local maxima. Which point? That point they mention. That point means we are assuming less than, greater than, no. That particular point. Got it, children? Thank you, children. You have to go through. If you have any doubt, whenever you want my help, I will help you. Right? Thank you, children.